Previously on Chemistry Talk with Dan.
Maybe this is what I need. Yes, to unravel the mystery, the periodic table. What was that?
And now the exciting conclusion.
I have followed the screen to this spot, which looks strangely like the last scene. But one mystery at a time. We have found some more strange markings on the wall, clearly left by a desperate individual as they are shuffling off this mortal coil. I shall attempt to decipher its meaning. Alright, so we start with atomic radius, which if I recall is the size of an atom. Yes, and using the clue that we found in the last scene, we know that the proton pull increases to the right as you go across the period, which means that the protons are getting stronger and pulling harder and harder on those electrons, thus making the atom smaller. Yes, so the atomic radius will decrease as you go to the right, but as you go down the group, the proton pull decreases and the electron shielding increases, meaning that the electrons are able to spread out, making the atom larger. Yes, so that means that our largest atoms are down here in the bottom left corner, and the top right corner are the smallest atoms, meaning this particular trend goes like this. Alright, ooh, this next one says electronegativity, which if I recall is the tendency of an atom to attract an electron. So, if proton pull is increasing across the period, then the atoms are able to attract more electrons. Yes, because there are more protons and they are stronger. So electronegativity must increase as you go to the right. But as you go down the group, then proton pull decreases and electron shielding increases, thereby allowing the atom to no longer be able to hold on to electrons as well. So electronegativity must decrease as you go down. So our weakest atoms in terms of electronegativity are down here in the bottom left, with the strongest electronegative atoms in the top right. So this particular trend must increase thusly. Now we see ionization energy. Alright, so the same rationale as before, as the proton pull increases to the right, ionization energy, which is the energy required to take an electron away from the atom. Yes, so if the proton pull is increasing, therefore it must be harder and harder to take away the electron. So ionization energy must increase to the right, but as you go down the group and proton pull decreases and electron shielding increases, therefore it becomes easier and easier to take an electron away from that atom. So it decreases as you go down. Thus, this trend is very similar to electronegativity and increases thusly. Alright, last but not least, ionic radius, which is the size of an ion, if I recall. Yes, alright, so cations versus anions. Well, cations are positive ions. Yes, they are not negative, they are positive ions, meaning they lose electrons, and when they lose electrons, there are now more protons than there are electrons, meaning that the proton pull must increase. Yes, they increase, thus allowing the ion to actually decrease in size, whereas anions, which are negative ions, they gain electrons to have that negative charge, thus leaving the protons outnumbered by the electrons. So the electrons are able to spread out a little bit more, thus making the ion larger. So if we are to compare cations to anions, it is clear that the anions are greater than the cations. Yes, they are larger than the cations. But if we are to compare the groups to each other, so group 1 will lose 1 electron, group 2 loses 2 electrons, and group 3 loses 3 electrons. In group 3, the proton pull is the strongest, and in group 1, the proton pull is the weakest, thus meaning that group 1 is larger than 2, which is larger than group 3. Alright, last code to decipher, 5, 6, and 7. Well, I wonder why there's no 4. Right, because in group 4, not every atom becomes an ion, so we cannot look at that. And there is no group 8 because group 8 are the noble gases and therefore are already stable and no ions. Yes, brilliant. All right, so 5, 6, and 7. So atoms in group 5 must gain 3 electrons in order to become an ion. Group 6 will gain 2 electrons, and group 7 will only gain 1 electron. Meaning that in group 5, the protons are outnumbered the most by the electrons, meaning the proton pull is the weakest, therefore allowing the atom to be the largest. And in group 7, with the only 1 extra electron, that proton pull is still stronger than the others, meaning that the atoms are smaller, or the ions are smaller. So in this case, yes, 5 is greater than 6, which is greater than 7. Yes, but we must remember that the anions are greater than the cations. So if we were to compare atoms within the same period on the periodic table, group 5 must be larger than 6, which is larger than 7, which is larger than 1, which is larger than 2, which is larger than 3. There you go. I knew I could solve the mystery. It's elementary, brother. Yes, elementary, my dear viewer. Elementary. I'm not Dan, and there are more mysteries for me to solve. Check you later.